Today I'm going to be doing an experiment for you all on how we can do some measurement at the nanoscale and how we can do it at home with very simple household materials and without any fancy instrumentation or expensive equipment. So the question that we're asking, that we're trying to solve with this experiment is, can we measure the size of a molecule, again, with our household items? So in this case, we're going to be looking at dish soap, which contains detergents. And most detergent molecules look something like this, where you have a long carbon chain on one end and a polar head group on the other. And so I'm going to show you how we can try to estimate the size of a molecule like this. So this has been an interesting area of study since a long time ago. One famous person who was interested in surface chemistry was Benjamin Franklin. And he famously sat at Clapham Pond and dropped a single drop of oil into the pond. And you can see the dramatic difference that it makes when you have no oil on the surface, and with a single drop, it makes this large patch here that you can see of reflective surface, and it calms the waves. So what is the reason for a single drop of oil being able to spread across a whole surface like this? Well, it has to do with the types of molecules. Specifically in olive oil, you have a molecule called oleic acid, which has, similar to the detergent molecules in soap, it has a head group, which is polar, which means that it likes to interact with water, so it's hydrophilic, and a tail group, which is a long carbon chain like we saw with the detergent molecule, and that's hydrophobic. And so these large molecules orient themselves on the surface of water so that the hydrophilic side is touching the water and the hydrophobic side is outside on the surface. So when you make a layer of a molecule like oil or detergent on water, it forms what's called a monolayer. So the molecules align themselves in a single layer on the surface. And knowing how to calculate the volume of a cylinder, we can then measure the size of the circle that's created on the water and calculate the height of the monolayer. So if you can measure the radius of your circle of water or of oil or detergent that's on the surface of water, and you know the volume of the molecule that you added, then you can estimate the height. Now in reality, a monolayer is going to look more like this extended flat cylinder rather than this one, but the math is the same. So for this experiment, the materials are very simple. You'll need a large pan or baking sheet with sides like this. You'll need a dropper for putting your drop of soap. You'll need some baby powder, and for me I put it in a little cotton bag like this so it's easy to get a little bit out at a time. A ruler just to measure the size of the width of your monolayer. You'll need some dish soap. I prefer to use dish soaps that are not ultra concentrated, so this ivory dish soap works pretty well. And just some normal tap water. So the first thing you need to do is just fill your pan up about halfway with water so that you have a decent amount of water in there. And then you're going to want to let that settle for a minute so that it's not too turbulent, because then that can affect your monolayer. So in the meantime, you'll want to dilute some of your dish soap. So dish soap as it is normally going to be way too concentrated and your monolayer would fill up the whole pan. So we have to dilute it. I found, at least for this type of soap, that it works quite well just to take a 1/4 teaspoon and add that to about 1/2 cup of water or 4 fluid ounces, depending on the type of measuring cup you have. So so first I'll try to get 4 fluid ounces in this measuring cup. And you want to be as accurate as possible with your measurements, because if your measurements are off, then your calculations can vary quite a bit. So I have 4 fluid ounces of water, and I'm just going to carefully add a 1/4 teaspoon of my dish soap into here. And I'm just going to use that same measuring spoon to mix it as well as I can without spilling. Okay. So by now the water in your pan is probably settled pretty well. And at this point you can very carefully tap some baby powder out onto the surface. So you really don't want to put too much baby powder, or else it'll clump up and that will affect your monolayer. And you don't want to let it sit for too long before you add the soap either, because then it will also clump up that way. All right, maybe I'll put just a little more. Okay, so just a very thin layer of baby powder on your water, and then take your dropper and this part can be a little tricky. You just want to make sure that you get exactly 1 drop of your soap solution on there, and you want to have your ruler handy. And basically drop a single drop, and then measure the diameter of your circle with the ruler as carefully as you can, and write that down, and then the rest is math. All right, so that's basically all you need for this experiment. So if you don't have all the materials that you need at home to do this experiment, we would recommend that you use an example data set, such as the one shown here, and you can still go through the calculations to calculate the height of a monolayer. So we normally recommend doing repeat trials of your experiment. So here's 3 repeat examples of the measurement for the diameter of the monolayer, and you can go through the calculations using this data.